Hello and welcome to the Kubernetes talk series. So today's agenda for the video will be about the fourth component of the Kubernetes architecture, that is scheduler. So let's discuss about the scheduler. The scheduler is a key component of the cluster that is responsible for scheduling and allocating workloads to available nodes in the cluster. It ensures efficient utilization of resources and helps ensure that workloads run smoothly in a Kubernetes environment. The scheduler takes into various factors such as how much resources required by a workload, how much resources are available on the nodes, and other things such as labels, tains, and toleration to determine the best node to run the workload. The scheduler can also be configured to take into account additional factors such as node affinity, anti-affinity rules, which allow user to specify preferred and forbidden node assignments for the pod. Let's discuss some points how scheduler works. So here we have the pending pods. Now what are pending pods? Pending pods are those where user creates a new pod. It is in a pending state until it is assigned to a node. Next is filtering. The scheduler filters the available nodes based on their capacities and any tains or labels that have been assigned to them. Prioritization. The scheduler then prioritizes the remaining nodes based on their ability to meet the resource requirements of the pods and other factors such as node utilization and constraints. Binding. The scheduler then binds the pod to the node that has been determined to be the best match. So let's understand with the help of diagram. So here we have a diagram. Let's say we have requested for the deployment. The deployment controller will create the pods and the pod object is created. Then scheduler comes into the picture. It will schedule the pods in the respective nodes. So here we have all the nodes. And then we are applying the filter. It could be anything like neighbors and node affinity, anti-affinity, tail toleration. And after considering that, we have some feasible schedules. And among these, the scores and rank has been given. So let's understand how these scores and ranks are given. So let's say you have a deployment which has requested for 25 milli CPUs. Okay. So S3 node has a space for 10 milli CPUs. So it is scores lowest. S1 has a space for 15 milli CPU. So it is scored as 4. S8 has a space for 25 milli CPU. So it is scored 7. And S4 has a space for 30 milli CPU. So it is scored as 8. Now, according to our assumption, S8 should be appropriate, but according to the scheduler, S4 node is suitable. Why? Because scheduler will only select the node where maximum resources will be available. Because in the S4 node, even after deployment is created, 5 milli CPU space will be there to perform the other task. So as a result, final solution S4 node will be selected and the pod will be assigned to it. So that's it for this video. We will discuss about Kube-Proxy in the next video.